relative structure of DNA is a double helix. Now what does this mean? It means there are two strands of DNA that wrap in a spiral manner about a common axis. DNA can either be left-handed or right-handed. This is similar to how a spiral staircase can go up in both a left-turning or right-turning fashion. An easy way to tell the handedness of any helix is to think of it as going up a staircase. If the outside rail is on your right side, it's right-handed, and if it's on the left, it's left-handed. Now we're going to take a look at some examples. As you can see in this first example, if you were to go up the staircase, then the outside rail would be on your left side, meaning this is left-handed. In the rest of these photos, you can clearly tell that they are all left-handed because if you were to put your hand on the outside rail, it would be on your left side. Now that we know what the overall DNA structure looks like, according to researchers Watson and Crick, I'm going to break down that structure to its basic components of nucleotides and bonds. One of the most basic components of DNA are the nitrogenous bases. There's cytosine, guanine, adenine, and thymine. Cytosine pairs with guanine and adenine pairs with thymine. This is referred to as base pairing. When many of these base pairs are next to one another, it's called base pair stacking or base stacking. Base pairing is because of hydrogen bonds. 2 hydrogen bonds pair adenine and thymine, and 3 hydrogen bonds pair cytosine and guanine. They are relatively weak and are not the main force joining the two strands of DNA. Other than these nitrogen bases, the two important components of DNA are its phosphate group and 5 carbon molecules, deoxyribose sugar. The importance of ribose carbons is that they provide the sites of linkage for phosphodiester bonds at the 5' and 3' carbons. Phosphodiester bonds are the main force joining DNA strands. The sugar and phosphates create the backbone of DNA, and the nitrogenous bases pair with one another. The backbones of winding DNA molecules also create grooves. The major groove occurs where the backbones are far apart, and the minor groove occurs where they are close together.